Let me ask you something before we begin. Have you ever stopped to think? Why the world around you doesn't fall apart? Why the lights stay on? Why airplanes don't simply drop from the sky? Why massive machines obey tiny signals? The answer is not magic, it's not luck, it's control systems. But control systems did not start with equations. They did not start with computers. They started with fear, and with a very human desire to make chaos behave. Today, I want to tell you the full story, not as a textbook, not as dry theory, but as a journey through control, protection, and how machines slowly learn to think and survive. So sit back, because this story begins long before control had a name. Imagine ancient humans, no electricity, no sensors, no algorithms, but still systems, water systems, fire systems, mechanical tools, and every system had the same enemy: uncontrolled behavior. Too much water? Flood. Too much fire? Death. Too much speed? Destruction. So what did humans do? They didn't optimize, they didn't control, they protected, they built barriers, they limited flows, they created physical constraints. Protection came first, and because survival always comes before performance. And slowly, something magical happened. Humans realized, if I observe the system and react to it, I can guide it. That idea, that simple idea, is called feedback. Let's talk about water. Ancient water clocks worked like this. Water flows in. The level rises. A float moves. The float restricts the inlet. No equations, no controllers. But the system observed itself and changed its behavior. That is feedback. And here's the key insight. Control and protection were the same thing at this stage. Prevent overflow, Sikung's protection, maintain level Feng's control. They were inseparable, but this would not last. Fast forward to the Industrial Revolution. Steam engines were powerful and terrifying. When speed increased uncontrollably, machines exploded. People died. This forced a new question. How do we regulate behavior automatically? Enter James Watt's centrifugal governor. As speed increased, balls moved outward. Steam input reduced, speed stabilized. For the first time in history, a machine controlled itself continuously. Control was born. But here's the twist. Even with control, explosions still happened. Why? Because control assumes normal conditions. And reality is never normal. So safety valves were added, emergency shutoffs, mechanical limits. And now, for the first time, control had one job. Protection had another. And the split began. Let's pause and clarify something important. Control systems exist too. Track references, maintain stability, improve performance, react smoothly. Control answers questions like how fast? How accurate? How efficient? Control is intelligent behavior. It is continuous. It is dynamic. It is ambitious. But it is also optimistic. Control assumes the world is reasonable. Protection does not assume anything. Protection is pessimistic by design. Protection asks, is this dangerous? Will damage occur? Should we stop everything right now? Protection does not optimize. It does not negotiate. Protection acts fast and often brutally. Trip, disconnect, isolate. Protection saves systems when control can't. This is where many engineers get confused. A perfect controller does not guarantee safety. Why? Because sensors can fail, models can be wrong, extreme events exist. Control is not designed for worst-case scenarios. So no, control is not protection. And the opposite is also true. A system relying only on protection shuts down often, wastes energy, ages quickly, becomes inefficient. Protection does not care about performance. So no, protection is not control. Here is the golden rule. Control handles intelligence. Protection handles survival. When they cooperate, control avoids dangerous zones, protection watches absolute limits, efficiency improves, failures decrease. When they don't, history is full of warnings, power grid blackouts, industrial accidents, cascading failures. In many cases, control pushed systems to their limits. Protection was misconfigured, coordination was missing. The result? Dark cities, destroyed equipment, lost lives. The lesson? Control and protection must be designed together. Today, systems are smarter than ever. Digital control, model predictive control, AI-based optimization, but protection remains conservative. Why? Because reliability beats intelligence when lives are at stake. Modern systems now aim for integrated architectures, shared data, hierarchical decisions. Control anticipates faults. Protection confirms reality. Control systems did not begin with math, they began with fear of chaos. Protection did not begin with relays, it began with instinct. And the future belongs to those who understand both. Because a system without control is blind. A system without protection is reckless. A system without both will not survive. If you enjoyed this journey, this is only the beginning. Because behind every smart machine, there is a story. If you like deep engineering stories like this, subscribe. Because the next episode, we go even deeper. Thanks for watching, stay safe, and stay curious.